Good afternoon, everyone. Thanks, Madam Chair, highly esteemed colleagues, and the scientific community at large. Um, I'm going to have a small talk about okay, how CHPC was used in one of our projects, which is SIMS for the Department of Science and Innovation. I know the name has changed now. It's Science, Technology and Innovation. Yeah, but it's something new. Where do I move? Okay, so the overview is as follows. Firstly, I'll mention a little bit about the science engagement program and then some of the challenges and the solution that was put in place. And then the initiative itself of science engagement will be touched on, how it was initialized, and then some of the SIMS activities and operations, including the development approach and some of our in-house tools that we used, DGAP there, and the collaboration between Software Architecture Solutions, which is my research group, and CHPC, and the infrastructure that we use from CHPC, how it outlines and the different components, and some of the internal attributes, which is the key performance indicators, which are used for the accountability bid to the by the DSI, yeah, and then some of the outlook of the infrastructure and some recommendations. So the Department of Science and Innovation funds the Science Engagement Program. The Science Engagement Program is an initiative aiming to educate the layman on the street so that they can basically use science as part of their decision making for their day-to-day activities. So basically, it allows the layman on the street to have socio-economic emancipation using science. So some of the challenges that we discovered in the science engagement program were that there was a lot of manual data management. During the activities, paper-based data would be captured, collated, and attempts would be made to analyze that data. And it happened to be quite a bit of data. So basically, establishing patterns and trying to assess future patterns became a challenge, and that stifled the DSI from basically accounting internally to its stakeholders and even externally to Parliament. So through legislature, what happened is the DSI was guided by their internal processes to actually come up with a system that can automate parts of the whole science engagement program. Then what happened is that the whole science engagement program ended up having to be digitalized. So there were key performance indicators which were going to be used, which were going to enable the DSI in order to account for the funds that they use on the science engagement program. So basically, in terms of the return on investment by the DSI and the accountability to internal and external stakeholders, the SIMS project was going to assist them from using manual processes which have got very limited data and very static data to more dynamic and more informative data, so that basically they can move from inefficient processes to very, very efficient processes when it comes to managing their data. And these are basically some of the activities and some of the reach of SIMS and some of the players, simple players like even schools and universities to the research community at large. All of those are involved in science engagement because science is used by those users for their decision making. So the development approach that was used by the SAS group for SIMS was basically the cloud-first approach. This was mainly dictated by legislature. Some of the advantages with this approach was high availability, and the systems can scale, even the environment, the infrastructure can scale, and the cost efficiency. Basically what happens is that the SaaS group doesn't have to manage its infrastructure anymore. External players would be able to manage that infrastructure. Hence the collaboration with CHPC, providing infrastructure as a service to the group. Then it means then that the SaaS group doesn't have to invest their resources, which is the developers, to manage the infrastructure, make sure that the infrastructure is up to date, and all of that goes to CHPC. An internal software factory called the Digital Government Application Platform, DGAP, was used by the SaaS group in order to implement SIMS. This factory is a huge application. We have a number of other applications other than SIMS which we have put on the platform. And on the platform itself as well, we have other APIs that can be used for initializing projects, and make sure that basically, for example, identity management is available for a project, special services, depending on the needs of a project. It doesn't mean that all the projects will require the similar resources, but the software factory is there, and based on the needs of the project will use whatever APIs it requires appropriately for initialization. So for the collaboration on the SaaS group and CHPC, as I mentioned earlier, the SaaS group is mainly on software development. So the SaaS group has got shortcomings basically in terms of provisioning of infrastructure, especially cloud, and it doesn't own dedicated infrastructure. We own servers, but they got outdated, and for us to basically acquire more servers and try and maintain them, it's just too much overhead, especially since we've got experts within our group, that being the CHPC. So it means then that the SaaS group doesn't even have to get resources in order to manage the infrastructure. That can just be shifted to CHPC, especially since CHPC specializes in infrastructure provisioning. That is your CPU, memory, and even disk space. So in terms of the infrastructure that's being used for SIMS, we have development environment, staging, and a testing environment. The staging environment is for internal testing within the business group itself, between the development team and the business. And then the user acceptance would be a testing environment between the SaaS group and an external client. In our case here, it would be the Department of Science and Innovation. The production environment was made to be multi-tier so as to minimize vulnerabilities and exploitation of the system. This is more or less the topology of the production environment. As I mentioned that it was multi-tier. The other environments are less complicated. What's important there is mainly the storage, because SIMS takes its data very important, and the identity management, where you have authorization and authentication, that is important for the SIMS project. And then the SIMS, in terms of components, it's got two core components. You have the public portal, wherein the members of the public can access the SIMS system, and then you have the back office of the system, where basically ratification processes are being done by the internal stakeholders of SIMS. This is how the SIMS public portal looks like. We try to make it as nice as possible for the general public. And this is also the public portal with some of the key activities being outlined there. You have the events application and the National Youth Service program. The other two components are just work in progress. They'll be rolled out either actually early next year at the very earliest. And this is the dashboard for the ratification, basically, where after a user has applied, a public user has applied to use SIMS, they can actually be ratified, or the operations that they wish to do, the activities that they wish to do as part of the science engagement program can be ratified before it can be made available to the general public. In this scenario, you'd see that it's the events. An entity will apply to do an event on SIMS. However, before it can actually, data can be captured on that event, it has to go through the ratification process. As you can see that as part of the ratification process, some events can actually be rejected, or they can go to other states wherein there's no data that's being captured for them. However, for auditing purposes, we need to be aware that these events went through the system, and basically information can be made available when necessary to our external stakeholders. For capturing of KPIs for this particular module, only successfully approved events would actually be captured, their KPIs. And this is more or less some of the KPIs, the reporting dashboards. It's also for events. This is for the previous year, which is 2023. It's just a snapshot. And some of the KPIs we can see there, disability, race, gender, and other KPIs as well on a different type graph. So in terms of advantages, what we have noticed is that basically CHPC is quite useful for the SIMS project. It's also a prototype. The SIMS project is a prototype for CHPC to assess its use in real life situations. Also, both the SIMS and the CHPC are under the parent group of the DSI. So basically, it's good return on investment for both the service provider and the consumer. And basically, it's cost efficiency across the board. And then some of the challenges that we have experienced as the SIMS group is that obviously there is intermittent downtime due to maintenance. However, we've been fortunate enough that CHPC communicates in advance so that we can mitigate or come up with basically other alternatives in terms of when there is a downtime. However, some of the systems, it's very difficult for us to switch them off, so maybe we suggest maybe that there should be a failover site or a recovery site, so that that is outside, so that the system doesn't suffer from downtime. Some of the overall performance, the National Science Week, which is a flagship for SIMS, and the National Youth Program, those two programs have done tremendously well on the CHPC platform, and the SIMS team is quite grateful to CHPC. And these are some of the stakeholders of the SIMS team. Yeah, it's basically the research community at large. Thank you.